So what we'll discuss today is a replication controller, replica set, and daemon set. Replication controller and replica set are similar. Replication controller is the older way of doing the same thing which replica set is doing currently. The reason we'll go through replication controller is because many applications or many configurations are still in replication controller. So it's good to know in case you need to deal with those applications. So replication controller, what it is and why do we need this? So in the past sessions we have discussed, you could create pods using YAML file where you give type pod. Generally we don't create pods directly. The reason we don't create pods directly is that if that pod cracks, if the container inside the pod is crashed, then pod will start the container. So that gets taken care. But what about when the pod itself has crashed, or the node where the pod is, that node itself has crashed? So then you can't restart that pod because you just created only pod. Generally you create deployments or application controllers which can create and manage pods also. So if you use either of these, we'll discuss deployments in some later sections. But if you use either of these, then if pod node crashes in node or which pod is deployed, if that crashes, then automatically a new pod gets created by these objects. This I already discussed. Node failure also gets detected. There can be pod failure and there can be node failure also. So node can remain intact, but pod can fail for whatever reason. So that pod will get started, or the node itself can fail. It can crash. And when you're dealing with clouds, your nodes, there's a high probability of nodes keep getting crashed. So that also gets handled. Now the way replication controller works is it operates on pods matching certain label selector, and we will see that. So how does this replication controller manage the pod? Let's say on node 1, you have pod 1 and pod B. Pod B is managed by replication controller. Pod 1 is not managed by replication controller. And then you have some other node which has some another pod running. Now let's say node 1 has crashed after some time. And when node 1 has crashed, this no longer exists. But because pod B was managed by replication controller, pod B gets restarted on some other node because replication controller is managing it. But pod A has gone for good because it was not managed by replication controller, for example. So how do you create a replication controller? So as with many, as with every object in Kubernetes, you can create using command line or API or YAML. So we'll use YAML here. We'll go through this YAML and then I will run and create one. Actually, let me start the, just give me a second. I will go through this, then I will start my Kubernetes and Docker. So this YAML, of course, the API version v1 at this moment. And here we are specifying kind is replication controller. Earlier we were specifying kind is pod or other things. So here it's replication controller. The name of this replication controller is, this is the name I have given. The spec, the replicas, I want to have 2 instances of this pod running. Selector, this is the selector I'm giving. And this should match what I'm giving in the template below. We'll go through this. This is a pod template. In pod template, you have metadata and your labels, and this, what value have, selector key value here, it should match to this key value here. Then you have spec, there should be indentation. So, forget my, wrong formatting here. So under spec, you have containers. It's the same, you are using the same, the name is this, image is this. Image pull policy is not present, and I'm opening 8080 port here, and this is the command. This we have been using in the port for a quite long time. So let's try to run this. Give me 1 second. So now we are going to create a replication controller. So before I do that, kubectl RC, I think that's what it is. There is no replication controller yet. So I will create one. And now replication controller got created. And now you can see the replication controller. It's desiring 2 pods and 2 are running. So I can see those pods also. kubectl get pods. So this pod was already running. So I will don't worry about this, but these two pods got started. And it's saying error image pull. For whatever reasons, the images it's not able to find. So mini cube KUB image ls min. So looks like I don't have that image here. That's why it's not able to find that image, and it's not on the Docker also. So that's why it's saying erase error image pull. I'll fix that image issue, but as you can see, right, it has the two pods started. Okay, and what is the version of the image I have given here? It is supposed to take image latest only. Okay, let's see. Okay, the image is not found here. So what I'm going to do now is I'm going to check if this image exists in Docker. Docker image ls. So these are the images. That image is here with version 9. So it's not there with version latest. So what I'm going to do now is I'm going to open that, my replication controller, and change it to version 9. REPL controller, and change this to version 9. And what was the 9.0? Latest instead of latest. Say 9.0. And I'm going to see if 9.0 exists here or not. I'm going to load it and then see it should work. Now let me get replication controller, and I'm seeing I'm using this java -docker_sh9, but still not able to find. Unable to add the image java docker sh. Oh, it is underscore. My mistake. Keep making mistakes. Let's load it right now here. I was playing around with certain things. I ended up changing the name of images, etc. So that's why it's causing this. So I have updated this again. I will say instead of hyphen, it's underscore. Save this. This is the thing. So let it load. It takes a while. While it is loading, I will run that command again. What I am going to do now is I am going to delete that application controller. So now what you're going to see is kubectl get pod. It will still be having, oh, somehow it's running because for whatever magic has happened, it found the image and it's running. So let's keep that here for time being. And now I am able to start the replication controller, and I'm able to see that kubectl get our series replication controller. This replication controller is running, and there are two pods it wants, and both pods have started. So the pod names will be this complete thing, then hyphen some characters which Kubernetes will put. So these are the two pods which are running. Now next one. What happens if I delete an existing pod? So delete existing pod. So I will delete using this kubectl delete pod command, and then we'll see what happens. So now I see these two pods, right? So I'll take one of these pods and I say kubectl delete pod. I can do this also. And I deleted it. Now let's see what happens. It again started something, the new one. So this one does not exist anymore because this is what was existing earlier. I deleted that, but then it started new one. This new one it started because replication controller wanted two pods to be there. It detected that one pod is not there anymore. And in the replica set here, if you see the setting of the replication controller, I said replica equal to 2. It always wanted 2. 1 was not there. Only 1 was there because I deleted the other one. So it started the new one to keep it, to keep the replica count to 2. So that's, to validate that, replication controller asserts or make sure the specified number of replicas of pods are running. So this we already did. Try deleting one port and then kubectl get ports. Then we'll see this, and we can always see the describe and everything. So I deleted that, and okay, this we have done. Describe. Let's see the describe replication controller and see what happens. So we have not done that. So where is the replication controller? We'll do that again. kubectl get rc. And we'll say kubectl describe rc descr. So this is what it is. So it says this is a selector. It is using selector and label replicas. There are 2 replicas it desires and 2 are running, and both are running. No one is waiting or failing or anything. The port, the command, whatever given in the YAML file, all gets displayed here, and it just tells which thing was running. So it was initially running these two. Then I deleted one of these 2 and started this one. So it prints that log also here. Let's describe this. We are done. Now what I'm going to do is let's run this command. kubectl get pod. You see 2 pods running. kubectl get rc. You see replication controller running. Now you say kubectl delete. Now I'm going to delete only the replication controller. So RC, and I'm going to give this and see what happens. Spelling mistake. kubectl, it deleted. Now you see RC does not exist. Sorry, this is the RC, it does not exist, and ports also don't exist, correct? Because port got created by replication controller. If port went, then replication controller. If replication controller went, then port also went. This is a port which I have been doing some work on, so it's already, so don't worry about this port. You can always create it back. This we already did. We have described it, and this we did. We did the kubectl delete. So generally, cascade files is a flag. If I give that, then see what happens. So what I'm going to do is I'm going to create the pod again, create the replication controller again. Where is that command? So kubectl create -f. So I created that. Now I will run the same thing again. You see replication controller created, you see pod created. Now I'm going to run the command again with this flag. I'm going to delete the replication controller with this flag. What is this flag? -fs cascade equal to false, and then see what happens. cascad equal to false. Okay. Now you see the replication controller is gone. There's no replication controller anymore. You see that here. But the pod it has started are still running. Why? Because I have said cascade equal false, means we don't cascade the deletion to the children object of pods. So that's what it means. Now I can go ahead and delete the pods. kubectl delete pod. This one. And then pod. Sorry, the next one. Got deleted. Now I say get pod. So now those pods are not there anymore. So if you, by default, if you build replication controller, pods automatically gets deleted, pods which got created by this replication controller. But if you give cascade equal to false, then only replication controller gets deleted and pods remain intact. So this is the flow. So replication controller, check the number of pods matching the label selector. We discussed the label selector here, right? And we'll go into more details of this. So this is a label selector app, this one, and the pod which you are creating also have this one. and replica is 2. As long as you have 2 ports with this label, replication controller is good. But what happens if the ports do not match? Is the match count same as desired the port code count? If it is less, then it creates a new port. Create a new port from the current template. And we saw that I deleted one port, then it ended up creating the new port. And I will show you in subsequent sections that it will create the new port with the same label anyway. Sometimes if you also end up creating port outside the replication controller and you also give the same label which replication controller is using, so the replica count of the pod will increase, and replication controller will check that. Although the pod got created by outside, it will check, okay, this is the pod you created which has the same level, and now the number of desired port count is more, so it will delete the extra port and keep the count same as desired. So that's how replication controller works. Now what we're going to do is, so replication controller manages ports that match its label selector. We discussed that. Port can be removed from replication controller by changing its label. Once we do that, then this port will become like any other manually created port. So what we are going to do is, we're going to see the labels of the port. So kubectl get ports, show labels. Oh, I forgot to create the replication controller. So let's do that. Now we'll see show labels. You see both have the same label. And of course, let's see the replication controller also while we are at it. Replication controller also exists. So now what you're going to do is change label of one of the port and see what happens. So how are you going to change the label of the port? So I'm going to write the exact same command, cube label port. Let's do this, kubectl label port, and I will choose some random port. I'm choosing this, and after that, app equal to, I can give anything, app equal to some random thing I will give. Then I have to give this -- override. We discussed that during the label time. over override. Now you see the ports. So it was for the random which I created is still there, but because replication controller detected that the number of ports with this label are less, so just 4 seconds ago it ended up creating new one, so that the number of ports with the same label are exactly matching the number of replica which I had given. Okay, so this is done. Okay, this we discussed in the label anyway, so forget that. Now you can change the template of port with below command. So let's see how to change the template. So you can say, clear this out, kubectl, then edit, then rc, edit, rc, and what's the name of our rc? I wanted to copy that, this one, Control C, Control V. Once you do that, then it opens an editor for you, automatically opens an editor, and you can change. You want to change replica to 3, or you want to make some other similar changes, you can go ahead and make those changes. And that's it. That's the, I'm not making any change, but you could always make the change, and then once you save it, then it will automatically execute that while saving itself. So that's one way, but it will be effective for, we'll open the new editor and you can change the template there. What I said was not correct here. It will be effective for new ports only. What do you mean by that? I make this the template, I change this template, and then I do not do anything. And the ports are same, nothing happens to the port, then no change. But if I delete, let's say I open this, open this, and I change something, let's say I change the image or something of this command, like the command option here. Then once I start a new pod, once a new pod gets started because of the pod crash or because I deleted the pod, then it has to start automatically new pod. Then these changes will be applicable. Okay, so let's read this. I did not read this. Please edit the object below. Lines beginning with the hash will be ignored. An empty file will abort the edit. If an error occurs while saving this file will be reopened for relevant failures. Yeah. So that it makes this editor make sure of that. All right. How do you do horizontal scaling of pods? You can change the number of replicas using this command to any number of replicas you want. But I discussed that you can do using edit also. You can change the number of things. We'll do both. We'll do both and see what happens. So right now, kubectl and get pod. So we have I should say show labels. Show labels. So I want to delete this because it's unnecessary running. kubectl delete pod this, and I will delete the another one which I had created for my some other testing. I'll delete this also. So now these are the two pods running, right? Now I run this command kubectl scale rc kubectl scale rc, and I give this, and then I give this -f replica is equal to 4. I will give 10 will be too much. My laptop is already heating up. Now I go to this and say you 4 ports the same level I've started. That's one way. And then we'll use the edit also, edit option. So we'll do the edit. Where did that go? Edit. And 4 were already there. I'll make it 5 here. Just to be sure, 5. Then I save this. Then I say 1, 2, 3, 4. 1, 2, 3. Sorry. We discussed that this changes because of let's check one more thing one more time. 1, 2, 3, 4. The changes in the edit won't be applicable till the new pod or something else happens. So that's why let's check the edit again. Oh, sorry, my mistake. It had how many it had running earlier? 4. Let's try to change it to 5. Let's see what happens. Let's try to change it to 5. 5. Now 5th one is created. See, the replica it's taking immediately, but if you make any other change, and don't make change to replica, and replica remains same, you make any other change, then it will take in the next pod creation, not in the existing pod. So now let's go and change it to 2 only. Let's see if it works. So I'll change it to 2. And I save this. Now let's see. It's terminating. It was 5. 2 terminated. 3 it was terminating. So now I do it again. Now I'll have 2. So that's how for replica changes it affects immediately. So this we already discussed. When you're deleting, you can delete only the replication controller and not the ports using this feature cascade equal to false, or you can delete both as well. Either you manually give cascade equal to true, or you just don't give this, then by default deleting the replication controller will delete the port as well. And that's what we saw when you deleted the replication controller, ports associated with that were gone. So that's about deleting. Now we'll move to the replica set. So replication controller is deprecated right now. We should use Replicaset instead. And the reason we went to replication controller is, as I discussed, right? Many applications configurations still have a replication controller. So you should know such object exists. The replica sets are created by higher level deployment resource. The replica set allows selecting pods which lacks or has a label key, regardless of label value. So this you didn't have in the replication controller. So here you can say the matching can be done on the label key, no matter what the value is, what value the label has. Our replication controller, RC means replication controller, RS means replica set. Replication controller can't match this environment equal to double or development or environment equal to production, but replica set can match both. A replica set can match all ports with just key also. I think we just discussed that it can match with all keys as well. So we'll define the replica set. So let's see the replica set thing. cat, sorry, cat and K8, K8. I think I renamed it. Let's search for set cat. Sorry, ls ls. So this is a replica set. So cat replica set. So this is I'm creating the replica set. This is the API version apps/v1. For different type of object, you might have different apps API version. For replica set, this is the API version. So kind is replica set. This is the name I'm giving. The number of replicas I'm giving 3, and the selector match label app Java tips backend. I think same I'm giving here, and it's the same policy, same image. Let's see if the latest exists or not, because I was not able to create the replication controller. So let's see. So kubectl get pods, so and get replication controller. So I'm going to terminate the replication controller and start the replica set. Delete replication controller / control B, deleted. Now I should not have any replication controller, neither should be ports. There are no ports. So what I'm going to do now is I'm going to create the replica set. So kubectl create some f. Okay, it got created. Pods are running, so it found the image, and I can check the instead of get pod, I can say replica set. So replica set is also running. So 3 desired, 3 current, and these are pods. So let's describe it just for our satisfaction. DSCRI describe replica set. This one namespace is default. These are the selectors. We are not using label or annotation. 3 replicas are running, 3 ports are running, and this is a port template, and this is what had happened. So now let's do one thing. I will get the ports and will describe one of the port also, just for curiosity. kubectl describe pod. All right, too much information. So this is what I wanted to check here. It is controlled by, this pod is controlled by this replica set service, this replica set object. So this is a name, namespace default, priority, node, it's running on this node, start time, label, of course, annotation we have not given, status running, IP address, it's controlled by this replica set. This it has this container, information about this container, and other things are usual things. Conditions, volumes, information is here. There's no node selector we have given, and the events. So it created this container, and all those things. Yes, good. So that's how replica set works. We have seen this create. We have gone through this describe also, and we have seen this kubectl get replica set command also. Now we'll delete it and see what happens. Let's try to delete it with cascade false and see if that works here also or not. It should work, but let's see that. It's a replica set and it's a pod, correct? Now kubectl delete replica set / this one, and say cascade CASCAD equal to false. CASCAD equal to false. Let's see what happens. Deleted. Now replica set does not exist anymore. Let's see pod. Oh, cascade works here also. So good. So what I'm going to do is I'm going to delete. I will delete those pods separately. So let's pause it here for today. We discussed this, and if you give cascade false, then cascade true, then it will delete the ports also, like it did for replication controller. We'll pause it here. Next time we'll discuss the daemon set, but what is daemon set, how you can configure and how you can run. So let's keep it for the next session. Thank you very much. And